Hi everyone. So this week we are going to learn about the second of the major transformations.
Human, I am back.
Oh, you've returned.
Well, I heard you were talking about transformations.
Okay, can you tell everyone who you are in case they didn't watch the first video?
I am Coordinate Prime, leader of the Congruobots. We are in a long-running battle with the Dilaticons.
Alright, so as I said, this week
This
we're
week
talking...
we are talking about reflections, which means I can flip left or right, up or down, on an axis, or just a line.
Yeah, reflections. This is geometry.
Wait, I didn't even mention on a diagonal. Wait, why are we transitioning? No!
Alright, so let's talk about reflections. So first we need to note some notation issues. When we transform a figure, we move the points. And when writing the new points, we use this notation. A, B, C, D becomes A prime, B prime, C prime, and D prime. Yes, much like our hero coordinate prime. So we write a reflection using this notation. It's a lowercase r and then in subscript, the line of reflection. So, all right, let's try this out a few times and see what happens. So here's our first one. We are reflecting A, which is at 2, 3. And then B at 0, 0. And C at 4, 0. Now we are reflecting this over the x-axis. So let's look at this right here. That's this line. So what you're going to notice is two of our points are already on the x-axis. So those points are not going to be... those points are not going to actually move because they are already on the line of reflection. It's like if you put your hand on a mirror, then it's right on your other hand. So, but for the third point, this was at 2, 3. But if it's reflecting, it goes down 3, 1, 2, 3, and then down 3 again to here. So there we go. So our points are 2, 3 became 2, comma, negative 3. 0, 0 did not move. And 4, 0 also did not move because it was on the line of reflection. All right, let's try another one. So in this case, we have G is at 0, comma 2. H is at negative 1, negative 2. And I is at negative 3, 1, 2, 3, positive 1, 2, 3, 4. So here's our points. Here's our shape. Now, in this case, the line of reflection is the y-axis, or our vertical line, right here. So once again, 0, 2 actually isn't going to move. That's going to stay the same because it is on our new line of reflection. But then negative 1, negative 2, well, it's 1 away from the line of reflection, so it's going to move to positive 1, negative 2. Notice that the negative 2 didn't change. And then finally, negative 3, negative 4, well, it moves 3 over to get to the line of reflection. And then over 3, that's going to get us right there, meaning that our point is at positive 3. Oh, let's rewrite that. Positive 3, 4. So G prime, H prime, I prime. So there we are. You'll notice it looks like a butterfly. Ooh. Finally, we have our last one, which is reflecting on y equals x, which is, by the way, this line right here. So let's look at our points. First, we have 2, negative 3. 1, 2, 3. Oh, I want to use the red for this. So 2, negative 3. 1, 2. And then negative 4, 1, 2, 3, 4, negative 2. So if I turn this over at about a 45-degree angle, which you could do on your phone or on your device if you wanted to, this is going to look a lot more clear. But to show you all kind of what you want to do here is it's kind of the same as what we've been doing before on counting how far it is to go. It's just now we kind of have to do it a little bit differently. So for instance, this point right here, I went down 1, but the reflection has to be the same. So in reality, this is the diagonal. And so this was half of the way, so this is the other half. But I'm going down 1 and then to the right 1. So every time I go down, I go to the right. Every time I go up, I will go to the left. So down 1, right 1, that's going to be my new M point. I'm actually going to use a different color for this one. M, which was at, so this is now at, okay, oh. So this was N, which is now at 2, 1. Okay, so now that we've chosen kind of the easiest point to do, let's do the other ones. So we have point N, M, which is at 2, -3. So if I would go 1, 2, 3, 4, 5. Then I would have to go in the other direction, 1, 2, 3, 4, 5. So that means that my new point is at 2, -3. Which is, or sorry, not 2, -3. -3, 2. So here we go. And then our final point is going to be, well, let's see. I go down 2, so I'd go to the right 2, which leads me to right here. And this point became -2, -4. Now you might be noticing that there's actually a really easy rule that we can use on this that's easier possibly than doing the counting thing I was just doing. And that brings us to our reflection rules. So let's look at them. If we are reflecting over the x-axis, so our x-axis, AB becomes A, -B. So when we reflect on the x-axis, the y value switches. Then, if we are reflecting over the y-axis, our y-axis, then AB becomes -AB, -A, B, which means when we reflect on the y-axis, our x value switches. Okay? And then finally, when we reflect over y equals x, our x and y switch because y is equal to x. So if y was originally 4, x is now 4. But if x was originally 2, y is now 2. That's the idea. So those are our big rules, and that's what you really need to know to be able to practice. And with that, I just want to tell you all to like and subscribe. So thank you very much. I hope that you all enjoyed the video, and there will be more videos like this next time when the transformations return with rotations. That's it. Bye.